Good afternoon, everybody. Welcome back to another grade 10 mathematical literacy class. We are currently in week 9. My name is Mike Geldenes, as many of you know. I'm not sure if we have any new students with us today, but if you are, welcome. And today we will focus on measuring and monitoring temperature. Okay, I hope that we will have another great class today. And remember, I love it when you guys interact with me, send me your questions, your answers, because I just want to see how you guys understand. And if you guys respond, then I know, you know what, maybe we should spend some more time on something. Or if everybody gives me a heads up, yes, Teacher Mike, we know you, it's okay, we understand. Also on the screen, you can see my email address, mgeldenes81@gmail.com. Please, if you haven't sent me any of your homework yet, or if you just want to ask a question, don't hesitate to send me an email. I'd love to hear more from you guys. Okay, so let's go straight into our lesson today. So let's quickly look at what we will be doing today. As I mentioned, measuring and monitoring temperature. We will focus again on some key concepts, measuring temperature, and then also recording and monitoring the results we get from that. First of all, we have to ask ourselves, what is temperature? Temperature is the measure of the warmth or coldness of a substance, an object or a substance, with a reference to some standard value scale. Okay, now who can tell me, how do we measure, what kind of scales are there that we can measure temperature in? What scale or what units can we measure temperature in? Okay, that is there we go. That is the instrument we use, yes, thermometer. But Nkosipile said, yes, degrees Celsius. Now, can you guys think of any other scale that we can measure temperature in? We're not going to use it because over here in South Africa, we use degrees Celsius, and we're going to stick with that. But I just want to see, just for interest, if you guys know of any other scales that we can measure temperature in. For example, in America, they don't really use Celsius. They use a different scale to measure temperature. Anybody? No? That's okay. Some other scales, first of all, like, I think, who was it? Who said first? Nkosipile, she said Celsius. Then there is also Fahrenheit and also Kelvin. Okay, all these start at different values. So, for example, Kelvin is minus 273 degrees. It's 0. So they all start at different values. So you need to make sure what you use, especially when you work with scientific temperature scale values. But we will stick to Celsius, so you don't have to worry about that. Another thing, I'm just going to go through some standard information or just some things about temperature. Temperature can be a negative or a positive, and the higher the positive temperature, the hotter it is, obviously, and then the lower the negative temperature, the colder it is. These are things we know, but I just want to run through them. Water freezes and becomes ice at 0 degrees Celsius, and at sea level, it boils at 100 degrees Celsius. Remember, the higher you move from sea level, the temperature at which water boils also comes down a bit. Okay, so let's say if you are in Cape Town, water will be closer to 100 degrees Celsius than if you are in Johannesburg. Maybe there it will be 96 or 95 degrees Celsius where it would start boiling. Okay, and then the normal temperature for a healthy person is between 36 and 37 degrees Celsius. Some measuring instruments, and I think here Mark gave us an example earlier. What do we use to measure temperature? What do we use to measure temperature? There we go, a thermometer. Now we will get all kinds of thermometers. We get an analog one, and the most common analog thermometer are used to measure your temperature. Okay, when you are sick, they can usually measure temperature from about 32 to 42 degrees Celsius. Why do you think those kind of thermometers will only show between 32 and 42 degrees Celsius? Can anybody tell me why do you think that would be the measurement on the thermometer? Does anybody have an idea? Why won't it start at 0? Let's see, anybody? No? Okay, maybe the chat is a bit slow again. I'm going to make, because that's the only range we need. If your temperature goes below 32 or above 42, then you are in serious trouble. So in that, we don't need the thermometer to show more than the range of 32 to 42. Okay, so we also get some outdoor thermometers. Those are just to measure the temperature outside. Now, here are our more recent thermometers, and that is an infrared thermometer. Now, this infers temperature by measuring the thermal radiation that an object emits. This means that the temperatures can be measured at a distance without having to be in direct contact with the object. Now, we see this a lot today, actually. Whenever you go to the mall, or if you go to a store somewhere you want to go inside, they measure your temperature with one of these digital infrared thermometers. They just scan your forehead to see if you have a fever. So it is something that kind of we get exposed to on an everyday basis with this COVID-19 thing going around. And then we get some very fancy, very state-of-the-art thermal imaging cameras. Now, these cameras will give you an image in colors. So a certain color would represent a certain heat. So it recognizes and captures different levels of infrared light. This light is invisible to the naked eye, but it can be felt as heat if the intensity is high enough. All objects emit some kind of infrared radiation, and is also a way that heat is transferred. Okay, so let's quickly look at those instruments. And remember, the same with everything that we've done this week: length, weight, volume. We use these instruments to measure temperature in different circumstances. Okay, so here we have our standard analog thermometer, the ones that mom would use to put underneath your tongue or under your arm to measure your temperature. Here are some digital ones, because remember the old ones had mercury inside. Now we have the digital thermometers. And then here's the one we see a lot today. Everybody uses these, the infrared thermometer, okay? Just so that they don't have to touch you or that they don't have to put something in your mouth. They just scan your forehead. And they actually use this a lot in the construction industry, electricians, when they want to see if a surface is hot. These are our standard outdoor ones that we just hang outside to see how hot or cold it is. And here are our fancy thermal imaging cameras. I hope you can see on the picture there, a certain heat will be represented in colors. Okay, so let's quickly look at an example. I'm going to go a little bit faster today because yesterday we got stuck a bit and we had to rush through our one question, and I don't want that to happen again today. So let's go right into our example. Natalia feels like she is getting sick and decides to measure her body temperature. Okay, using a thermometer once a day for a week to see if she is developing a fever. She knows that if her temperature rises above 35 degrees Celsius, she needs to see a doctor because this means she has an infection. Natalia records the following values. Okay, so we have our day, each day, Monday to Sunday, and then the temperature she took on each day. Okay, so I see Mark says he's seen that one before. Are you talking about the infrared or the thermal cameras? The place where we see those, just before because I see the place where we see those most, if you go to the airport, they have them normally if you go through certain gates. You can see as people pass by, you can see their silhouette, and then their silhouette would be in certain colors. And then depending on whether you have a fever or not, you will be in a different color than other people. Okay, but let's go back to the example. Here are our questions relating to this example. What will be our lowest temperature she recorded? The highest temperature she recorded? What is the difference between those temperatures? On what day was she the most ill? And then the last one, draw a line graph plotting the information in the table. Okay, so let's break it down. Here we have our table again. Question 1. What is the lowest temperature she recorded? So who can answer that for me? We've got the table on top. What is the lowest temperature? There we go, Megan. Yes, her lowest temperature, if we look at the table, would be on Monday, the first day, and that was 36 degrees Celsius. Easy enough, we just read the table. Question 2, what is the highest temperature she recorded? We can just go down and check, and we will see that will be 37.6. There we go. Thank you, Tiro. Well, I don't know why that's not coming in one by one. So let me here see the question. What is the difference between the two? So we will just take the 37.6 degrees minus 36 degrees, and it gives us a difference of 1,6 degrees Celsius. That's the difference between the two temperatures. Okay. Part 4. What day was she the most ill? So we will go back to our table, and then we will just look on what day was she the most ill. You can answer that for me quickly. On what day was she most ill? So we will presume that the day her temperature was the highest was the day that she was most ill. Yes, and as Megan states, it is, or it was, on Thursday. Now part 5. Part 5 of our question, it says draw a line graph plotting the information. Okay, so what we have to do is we have to draw our two axes, and that would be our horizontal and vertical. So on our horizontal, we place the day of the week. Okay, our day of the week, and we can see here Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, and remember, if we want to put in our values on this side, we only have two units we are using with, so it's the day and the temperature. So we know on this side we will put in the temperature in degrees Celsius. And remember, if we want to get the value that we're going to work in, we just always have to go and look at if they don't want you to start at 0, we can always just go and look at what was the lowest, and we've got that in our answer already, 36, and we know what the highest is, 37. So down here, we can, on our vertical axis, we can see our highest is 37,6, and then 36 is our lowest. And then something you can decide if you want to add a few on top and on bottom, just to not make it run directly from the line or from the corner. That's up to you. But then we can just go day by day and plot that then on our graph. So Monday, we check Monday and 36. And then where they meet, we will just make our mark. Okay. And then we will do the same. Tuesday, 36.3. And remember, to make it easier on yourself, you can see this is our temperature goes up in 2 degrees. Okay, so because if we make it too big, you're going to guess where you have to draw. So this is just a nice scale we can use. Wednesday, 36.7. Thursday, there was a big spike in her temperature all the way up to 37,6. Friday, it came down slightly. And then Saturday, a big drop, so she must have started getting better. And then on Sunday, it was basically back to normal. Okay, so that is just a quick example. So let's work through some activities. This is where I want you guys to get involved and help me out so we can quickly do this. Okay, measuring temperature. The following weather report appears in a local newspaper in George in the Western Cape. It gives the exact expected temperatures for one day in winter. Okay, so let's look at reading the weather report. There we've got the map again. And if we look at the map, remember the first thing we always do with questions is we find out what do we know. Okay, so if we look at this, we can just see it's part of South Africa, and there's a couple of towns or cities represented on the map with two values, one in blue and one in red. Okay, so explain why there are two temperatures given next to each town. Who can quickly explain to me why do they give two? And I think we all know this, but I like giving you guys a turn to answer the questions for us. So why are there two temperatures given next to each town? One in blue and one in orange. Let's see, highest and lowest for the day. Great, thank you, Tiro, that's perfect. Yes, the first temperature is the expected minimum temperature. That's the one in blue. And the second one is the expected maximum temperature. Megan says red is the highest and blue is the lowest. It gives us the max temp for the day. Beautiful, well done, guys. Number 2, which is the coldest city? So now we can go look on our map and we find the coldest city? So let's quickly see. You can find the coldest city first. You can find the coldest. What city is the coldest? Ooh, Megan's found it already. Yes, if we look on our map, the coldest city would be Kimberley, and it had a temperature of -3 degrees Celsius. Okay, so right, and then let's quickly ask, which is the warmest town? Let's quickly see if you can find the warmest town. Okay, I think Megan, I didn't even finish the question. She already found it. Yes, if we look down here on our map, our warmest town is George with a, thank you, Tiro, yes, with a high of 18 degrees Celsius. Okay, Nkosi Pile, well done, guys. Okay, so this is still easy enough, right? What is the difference between the two temperatures given for Alexander Bay? So again, we have to go and find Alexander Bay on our map. And we can see it's right here, just below Namibia. So we have, there we go. Megan has already given me the answer. We have a high of 15 degrees Celsius, and we have a low of 5 degrees Celsius. So we will minus the low from the high, and we will get the difference of 10 degrees Celsius. Well done, guys. Okay. Part 5. Now, what is the difference between the two temperatures given in the R? Again, we go to our map and we find the R. Here we go, right in the middle. And Megan says 14 degrees. Okay, so here we just have to be careful just a little bit, because remember our high is 12 degrees and our low is -2. Our low is -2. So if we want to get a difference, we minus, but because then now we have two minuses right next to each other, so we multiply them out, we get a plus. So 12 plus 2, and Megan is 100% correct. We get the difference between the two temperatures given for the R is 15 degrees Celsius. Okay, does everybody understand what we did there? Remember, just give me a yes or no in the comment section, so I know that we are all on the same page. Yes, yes, yes. Nkosi Pile says yes. Megan says yes. Okay, we all understand. Great. Okay, so let's move on to part 6. Harry is planning to drive from Cape Town to Beaufort West on the day for which these temperatures are forecast. Should he pack warm clothes? Explain your answer. So first of all, we have to go and look. Where is Harry coming from? He is coming from Cape Town, and he wants to go to Beaufort West. Okay, so let's see, what do you guys think? Do you guys think Harry needs to pack some warm clothes? What do you think? Do you guys think Harry needs to pack? Yes, there is a temperature drop. That's what Megan says. Anybody else? What do you think? Tiro, yeah. Yes, Cape Town is a high of 16 and a low of 10. But if he's going to Beaufort West, his maximum temperature is the same as that of Cape Town's minimum temperature. So yes, he is definitely going to be cold if he gets to Beaufort West. So yes, Beaufort West is significantly colder than Cape Town. Well done, guys. Let's look at our activity 2. Again, we have a table with some dates and some temperatures. Amy lives in Polokwane. She finds the following weather forecast for her city in the newspaper. Okay, here we've got this is for the entire week, from Wednesday to Sunday. And then here we have again all our maximum temperatures and our minimum temperatures. Okay, so let's quickly look at what we need to do for this question. First one is going to be, what day is supposed to be the hottest? On this hottest day, what will the difference be between the maximum and minimum temperatures? Number 3 will be, what is the difference between the minimum temperature on Wednesday and the maximum temperature or the minimum temperature on Sunday? And then also draw a graph of the maximum temperatures. Okay, so let's break it down. There's our table for us to work with, so we don't have to jump from one slide to the next. I added it in there. Number 1, what day is supposed to be the hottest? We just go to our table, and I think we already had some answers in here. You can quickly answer that for me again. What is supposed to be the hottest day? We will only work with maximum temperature. Yes, Megan says Friday. And we can see on those days, 23 Wednesday, 26 Thursday, 29 Friday, 25 Saturday, and 26 on Sunday. I think it's Shanice, Megan. Yes, guys, Friday will be our hottest day. Number 2, on this hottest day, what will the difference between the maximum and the minimum temperature be? I want you guys to also, if you can, write or type the equation for me, or type what you did, because I can already see we've got the right answer. Oh, I think we've got, no, we don't have the right answer. Megan said 10. I've only got one answer. I'm going to wait until I see at least one more. What will be the difference? Tiro. Yes, Tiro, nice. Tiro said the difference will be 9. Shanice, yes, great, guys. Because the hottest or the max temperature will be 29, and then our minimum temperature will be 20, and we will just minus that, and we get a difference of 9 degrees Celsius. Okay. Question 3. What is the difference between the minimum temperature on Wednesday and the minimum temperature on Sunday? So we know we're only going to work with minimum. We're going to look for Wednesday, and we're going to look for Sunday. Sunday, there we go. Thank you, Megan. This is nice equation. There's 18 minus 5. Shanice, yes, great, guys. So 18 degrees for Sunday, 15 degrees for Wednesday. That gives us a difference of 3 degrees Celsius. Well, it seems like you guys are understanding this very well. Okay, let's just get our information back here, and then let's look at, now part 4 said, let's plot the information on a graph. Okay, so we've got our graph, and remember we only have two units that we are going to deal with here. We still have our day. Don't know what's happening over there. Let me quickly just change to my pointer in my pen. There we go. We have day, and then we have temperature. Okay, we also have, so we will draw on our horizontal axis. We will make day of the week, Wednesday to Sunday. And then again, remember, we only have to work with the range that we have. So the lowest we can see is Wednesday. The lowest is Wednesday, 23, and the highest is on Friday, 29. So here we went a little lower, so we've got 22 over here in the corner, and we went all the way up to 30. Okay, so now what do we have to do? We have to go day by day. Day by day, we can just plot our temperature, okay? So first of all, we look for 20, where's 23 on our vertical axis? And then we see it's over here. We go all the way there and we connect with Wednesday, and we just mark that on our graph. And we will go through each and every single day like that. On Thursday, Friday, Saturday, we can see there was a big drop, and then Sunday. And then obviously we just need to remember to connect. Okay, so if they ask you to plot a graph, that would be easy enough to do, right? Does everybody understand how we go about plotting temperature on a graph? We will just mark it. Let me just see. Yep, Megan says she understands. Megan is great. Everybody else, do you understand? Yes. Nkosi Pile says she's fine. Tira says yes. Okay. What I actually wanted to do, because I didn't think about this, I wanted to plot the minimum temperature with you guys as we actually work. But now, because I've already made our graph and I just copied it in, we start at 23, but our lowest temperature will be 15, so we can't use the same one. But what I'm going to do, no, well, it's fine, it doesn't matter. We will skip that part for now. So, but even if let's say, for example, I asked you then, you know what, we'll plot the minimum temperatures as well. So then you would use the same type of graph, days, weeks. What I'm going to do, I want to show you, because I've seen many questions like this where they ask you, does it follow the same pattern? So I'm going to pretend, let's just pretend here and make this 15. Let's see if I can write here. Let's do this, because I know I can type on my no, I cannot. 15, let's make, so we'll just make this one 16, 17, and then we will just check to see whether or not it follows the same pattern. 18, 19, I'm writing so ugly now, 20, 21, and 22 is our highest. Okay, so let's pretend 15 is down here, so let's mark that with an X over here on Wednesday. 16 on Thursday, so 16 would be over here. Friday, it goes all the way up to 20. So 20 will be here by 28. So Friday will be over here. Saturday, 22, it drops down a little bit. Oh no, so it goes up still more. 22 will then be over, 22 will be over here. And then 18 again, all the way. Just want to make sure I put it on the right spaces. Sunday, 18 over here. Let's quickly change our color of my pen. Let's make it a nice blue, and we will draw the line for our minimum temperatures. There, 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 and there. So does that follow the same pattern as our maximum temperatures? Does that follow the same pattern as our maximum temperatures? Anybody? Yes, yeah. Now if we look here, the pattern for our maximum, it went up, up, down, and a little bit up. Our minimum temperature just went all the way up, 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 and dropped down a little bit. So does that follow the same pattern? No, there we go. Nkosipile, yes, it doesn't follow the same pattern. Okay, so just because a town's minimum temperature is lower or higher than another town doesn't mean that the maximum will follow the same thing. So certain towns will have a cooler morning but a hotter afternoon. So this is just a nice representation to see, you know what, how to plot this on a graph to see how different days would be different from others. Okay, so today went a lot better than yesterday. Yesterday we struggled a little bit. So what I do want to tell you guys as well about tomorrow. Tomorrow, so this is just your invitation to join us again tomorrow. Tomorrow we'll be doing a little bit of an assessment on Kahoot, okay? And we will have some questions about everything that we have done together. If you haven't been with us for the entire 2-3 weeks now, that's okay, don't worry. This is also just for us to see a little bit more how you guys are progressing and also just to have a bit of fun, okay? Yes, that was so fast today, Atira. We are already done. We've gone through both our examples and both our activities already. Yesterday, we got stuck on number 2 a little bit. But then for tomorrow, it will be all the work that we have done, okay? So probability, financial documents and tariff systems, and then measurements, measuring length, weight, volume, and temperature, okay? So I want you guys to join us tomorrow. I also want to share some news with you guys. Unfortunately, from next week, I won't be with you guys anymore. Somebody else will be teaching you from next week. And I'm going to miss you guys so much because I've really enjoyed teaching you guys, and you guys have been absolutely great. But that's why I really want you guys to come back tomorrow. We will do the Kahoot together, and we will just have some fun and see how you guys are, how you guys have progressed. One thing I do want to say as well, it would be beneficial if you can have a second device tomorrow, maybe a cell phone. I know some of you have played Kahoot with us before, but maybe not all of you have. So if it's possible, bring a second device. It's just easier to answer the questions if you can look on because I will show you all the questions on my screen. And then from your phone or a tablet, you can go into Kahoot, and then it's a nice colorful platform where you can answer the questions. And it is what's nice about it. Yes, it tests us. It's a nice test, but it's also fun because the faster you can answer, the more points you get. There's a leaderboard, so we will just have some fun together. Okay. And then here are our helpful links. You can go work through some extra examples or just find out some more information on these websites, www siabula.com, and then www.education.gov.za. Okay, and then you guys can also find us on social media, Facebook and YouTube, Twitter, African Teen Geeks, and Lockdown School, hashtag, or STEM Champions on Twitter. And for more information, you can find, or you can ask us some questions on info@Africa Teen Geeks. But thank you so much for joining us, guys. It was nice to have you with us again. And remember, send me your homework. I know I've given you some homework the other day that you have to plot out over a course of a couple of days. And I really look forward to hearing from you guys, especially seeing that tomorrow will be our last lesson together. So remember, I'm going to quickly post my email address in the chat as well, so you can just copy it. But I really want to hear from you. Otherwise, I want you to say have a wonderful day, and thank you for joining us again. Goodbye.